Hello everyone. In this clip today I'm going to go over two sections in chapter 3. 3.4 is about chain rules. This is a very important rules that help you to solve a lot of derivative problem. And then 3.5 is about implicit differentiation. And so you take the derivative implicitly. Okay, let's start with 3.4, chain rule. Besides the product rules and the quotient rule that we learned last time, chain rule is also very important to help you to take derivative. So you learned this before. Say f of x equal to sine x. And you know that the derivative of f of x is cosine x, right? It's just because the variable is x and we have sine of just x as well. What if our function is not that simple? What if your function is f of x equal to sine, say, 3x squared minus 2x. You see? So it's not just a single x anymore. And the derivative of f of x will not be equal to cosine of 3x squared minus 2x. Okay? Because the variable is not just x, it's the whole thing. The chain rule is going to help you to solve this type of problem whenever you have a big mass as a variable. So the idea is this. You're going to think of the whole mass inside the sine function right here as a letter u. So this function is no more than sine u, right? And the chain rule says this. Taking the derivative, you're going to take the derivative of that sine u, and then you times u prime. Whatever mass that you have, multiply by u prime. And so this is what? Sine prime of u, which is, what is the derivative of sine? Is cosine of u. And then times u prime, which is that mass prime, okay, which is 3x squared minus 2x derivative. And you know that u is 3x squared minus 2x, right? So this is cosine of 3x squared minus 2x, and then you times 6x minus 2. You guys see where I got 6x minus 2 from? The root of 3x squared. This is my square, all right? Bring the 2 down, 3 times 2 is 6, and then x squared, lower the degree by 1, so you got 6x, and then the root of 2x is 2. Okay, that will be the answer. And it turns out that left notation is pretty useful in this type of derivative. Recall the limit notation, df over dx, right? So whatever you have, the u as the intermediate values, you have this df over dx is equal to df over du times du over dx. See, an example right here. This is you take the derivative of function f with the variable u, and then you time the derivative of function u with the variable x. And in the example right here, show you. Okay. Go over this one more time. You have a complicated function, sine of 3x squared minus 2x, okay? You think of u as 3x squared minus 2x. So you simplify, kind of simplify the function, make it look like sine of u, okay? Now you want to take the derivative df or dx, the derivative function f prime, in terms of x, okay? But the variable now is not x, it's u. So you take the derivative of sine u in terms of u, and don't forget to multiply of the derivative of u in terms of it. So left notation is more powerful than here. It's clearer. Say what? This is df over du, and that means the derivative of f in terms of the variable u, and then time the derivative of the function u in terms of variable x. Okay? So this is what I just wrote before. This is what? Sine u derivative, and this is u prime, du over dx, right? Sine u derivative is cosine of u. And then u prime here is 6x minus 2, and cosine of u is cosine of 3x squared minus 2x, and times 6x minus 2. That will be your answer. And more than that, you may not have just one chain, right? From f to x, you have a u as one variable. You can think of it this way. df over dv times dv over dw times dw over du times du over dx. See? So what? If you have a very complicated function that need to do substitution several times to simplify the f. V, right? V of w, and then w over u, and then u of f. See, kind of cancel out. And that is the idea of the chain rules. So I guess the idea is not too hard, but let me give you a bunch of examples. Make sure that you guys understand the chain rule. Okay. Let me just write chain rules in here in short. I wrote already. I'll be writing here for you guys to take note. df over dx is equal to df over du times du over dx. Chain rule. Okay. Example. Say f of x equal to 5x squared minus 7x plus 1, everything raised to the 7th. Now I want to take the derivative of this. What is f prime? This time let me use the limit notation. What is df over dx equal to? Alright, I see that what I have in here is a big mass raised to the 7, right? So first time doing this, we do step by step. You think of u equal to 5x squared minus 7x plus 1. See? I let the whole thing inside the parentheses, that's the letter u. So this problem is no more than u to the 7. Now it looks simple, right? U to the 7. You know the derivative is 7 times u to the 6. So the derivative of this, according to the chain rule, df over dx will be equal to df over du times du over dx. Okay? So the u can cancel out. So this is u to the 7. What is the derivative of u to the 7? It's going to be 7 times u to the 6. Okay? What is du over dx? Du over dx is derivative. I'll do it right here. 5 and x squared derivative is 10x. I'll bring the 2 down. 5 times 2 is 10. And x minus 7. And the derivative constant 1 is 0. Okay? And then we write a u in terms of x. You have 7 times 5x squared minus 7x plus 1 raised to the 6th power, because this is my u to the 6th. And then times 10x minus 7. And you have the answer. Okay, that's the chain rule. Let's try one more example on the chain rule for just one chain before we move on to a more complicated chain rule problem. So, say I got this. F of x equal to e to the sine x. Okay, this is my e to the sine x. And if you know that you have e to the x, the derivative of e to the x is just e to the x. But our problem is not that simple. You don't have e to the x, you have e to the sine x. So I have to simplify. I let u equal to sine x. So my problem becomes e to the u. I'm going to use the chain rules. So df over dx, which means f right in here, is df over du times du over dx. Okay? Alright, what is the f of du? E to the u. The derivative is just e to the u. U is sine x, the derivative of u in terms of x. The derivative of sine x is cosine of x. Alright? And now you rewrite u in terms of x. You got e to the sine x times cosine x. And that will be your answer. So far, so good. How about another example? Let me develop this example right here. What if I got f of x equal to e to the sine of x to the 5th? Oh boy, in here you don't have sine x anymore, sine of x to the 5th. And you want to take the derivative of this one, think of chain rules again. Let u equal to sine of x to the 5th. So this problem is e to the u, is that right? The thing is, du over dx is not simple because you don't have sine x in here. The derivative of sine x is cosine x, but this is sine of x to the 5th. So I have to do another sub. I let v equal to x to the 5th. So this problem becomes what? Sine of v. Okay? Now this is simple enough. Sine of v, the derivative is cosine of v. So our problem have two chains in here. df over dx. We have first u, so df over du times du over dv, and then time dv over dx. Okay, let's do one by one. Let me rewrite this in more in a bigger space, so we have the whole thing right here. df over dx equal df over du time du over dv and time dv over dx. Okay, do one thing at a time. What is df over du? Right here, e to the u, derivative is e to the u. du over dv, right here, sine v, derivative is cosine v. What is dv over dx? Is 5x to the 4. Now replace the uv by whatever you have. E to the u is e to the sine x to the 5th time cosine of v, v is x to the 5th, so cosine of v is cosine of x to the 5th, and then time 5x to the 4. See, you have the answer. This is df over dx. And you see the use of the Leibniz notation is pretty powerful. It helps you to see the chain rule much better. Let's try another chain rule because this problem is going to be a little bit longer. One more step, one more chain in here. F of x equal to e to the sine of x to the 5th plus 7x squared, everything raised to the 4th power. Oh boy, this is going to be a very complicated one, alright? We have many steps in here. We're going to do one at a time. You see e to the whole thing, right? So I let u equal to sine of x to the 5th plus 7x squared, everything raised to the 4th. But this problem simplified to e to the u, which is what we need. Very good. But the u right here is not simple yet. It's going to be a big thing. So I see I have a sine function. I'm going to let v equal to x to the 5th plus 7x squared, everything to the 4th. So my u is no more than sine of v. Looks great, huh? But v is not simple yet. V is still a big mess. And I see that some mass raised to the 4. I let w equal to x to the 5th plus 7x squared. Then u now is w to the 4th, which is simple enough for me. Now, w is easy to calculate, derivative. Right? dw over dx is dw over dx is going to be 5x plus 14. 5x to the 4, I mean, plus 14x. I'll bring the 5 down, x to the 4, right? And then 7 that's constant outside, 2, bring it down, 7 times 2 is 14, and x to the 1st. Now, I can take care of the whole problem because I break down every single change that we have in here. So, df over dx will be df over du times du over dv times dv over dw and times dw over dx. Okay? I guess I need more room to write, so let me bring it up here one more time. df over dx is equal to df over du times du over dv times dv over dw times dw over dx. Okay, so the u cancels out, the v cancels out, the w cancels out. It's really df over dx. So let's do one chain at a time. df over du. df over du, e to the u, derivative is e to the u. du over dv. U right here, sine v, derivative is cosine v. And v over w. So v is w to the 4th, derivative is, let's make parentheses to separate them. Derivative is 4 times w to the 3rd. And what is dw over dx? dw over dx is 5x to the 4 plus 14x. Okay? Now you guys, all you have to do is rewrite everything in terms of x, and you're done. E to the u is e to the sine of x to the fifth plus 7x squared, everything raised to the fourth, because my u is that much. I'll replace this, right? And then times cosine of v. What is v? Cosine of x to the fifth plus 7x squared raised to the 4. And then times 4. I'm running out of space, so let me go down here. Times what? 4 times w to the third. My w is this, so 4 times x to the fifth plus 7x squared raised to the third power, and then times 5x to the 4 plus 14x. This is the derivative of this function right here. And you see, chain rules are very, very powerful tools that help you to take the derivative of complicated function by doing one chain at a time. Do a simple substitution to simplify the function, make it look simpler, one step at a time. So this one, how many steps you have? 1, u, v, w, like 3 chains in here. All right, hopefully the example will help you to get an idea of the chain rule. Please spend some time in practice, and you're going to master your skills. Next, I'm going to move on to section 3.5. I'll be talking about implicit differentiation. For the explicit function, this is implicit, because explicit you got what? Y equal to something in terms of x, or f of x, right? Y with f of x. F of x equals, say, 3x squared minus 4x plus 1, right? And you take the derivative of f prime of x. This is what we learned so far. Okay? Or in short, let me write this way: y equal to 3x squared minus 4x plus 1. And you want to calculate f prime, which means y prime, which is 6x minus 4. That's explicit. Okay? And many cases you don't have a function, I should not say function, an equation that looked at nice anymore. You may have something like this. Say 3y squared minus 7xy plus 4x squared minus 3x plus 1 equal to 0. Now, I want you to think x as a variable and y is a function of x. So this one is no more than this. 3 f of x squared minus 7x times f of x plus 4x squared minus 3x plus 1 equal to 0. And the question is asked you to calculate f prime of x. Of course, now you don't have a simple answer in terms of x anymore. You're going to have an implicit answer. Okay? So instead of writing f of x, it looks more complicated. It looks more difficult and longer, so we're going to replace y for f of x. But I really, really want you to think of y as a function in terms of x. Y now is not a variable anymore. Okay. Now, I'm going to write this way, make it easy. Now I want to take the derivative of this. Just simply take the derivative of both sides. Just be aware that y is not the variable. Y is a function. Okay? So how do we take care of this? 3y squared. 3 is a constant outside. Think of the chain rule in here. Like y squared, the derivative is what? 2 times y, right? And then in the chain rule say what? You have to multiply by the substitution. So y prime. We good? Okay. Now, minus, this one is a product rule. 7 in front. I have two functions, x times y. The product rule say what? Derivative of product is derivative of first times the second plus derivative of second times the first. Okay? The derivative of x is 1. So this is just 1 and then times y. So 7 minus 7y. Okay? Put in parentheses before we simplify. And the derivative second term, y prime. Keep in mind that y is not a variable. Y is a function. So y prime, you've got to leave it alone. And times x. Okay? 7 is outside the whole thing, right? You got this is just y plus y prime x. Plug in here. And now the next term is turn out simple because we don't have any y in here. The derivative of 4x squared is 8x. The derivative of negative 3x is negative 3. The derivative of 1 is 0. And the derivative of 0, of course, equal to 0. So I guess the hardest part is right here. Okay? Let me just finish the problem and I'll explain about this more. Talk about that more. 6y times y prime minus 7y minus 7y prime x. You see, I distribute a negative 7 into the 2 term plus, not 6, 8x minus 3 equal to 0. To solve for y prime, you're going to group the y prime together. I got what? Factor out the y prime. 6y, first term right here, minus 7x. I got minus some with that term. And then bring all the other term without the y prime on the other side. So 7y minus 8x plus 3. Okay? Bring that 7y to the right, subtract 8x, and then plus 3. Okay? And then the y prime to my factor, the y prime out, I got 6x, and then minus, 6y, and then minus 7x. Now all I have to do is divide both sides by 6x minus 6y minus 7x. So y prime is 7y minus 8x plus 3 all over 6y minus 7x. Okay? Now, let's talk about this term right here. Y, this is equal to 3 times 2 times y prime. Think of this function. How about this? F of x is equal to 3 times 4x squared minus 1 squared, for example. I just make up a problem. Okay? And I ask you to find the root of that thing. You see that this is a mass square, right? So you cannot take the derivative directly unless you factor them out and you take the derivative one term at a time. But I want to use chain rule here. I'll let y equal to 4x squared minus 1. The intermediate variable in here. So the problem is no more than 3y squared. You see, if I do y equal to 4x squared minus 1. So here, df over dx is really df over dy times dy over dx. Okay? So what is dy over dx? It's really y prime, right? Which is 8x minus 1 derivative is 0. Okay? And df over dy is the derivative of that one, right? It's 6y. So this is what? df over dx is equal to 6 times y, and this is y prime. 6y times y prime. That's what it is. And in this particular example, the y is 4x squared minus 1, so the derivative you know is going to be 8y. But in this problem right here, I don't know what y is, so I'll just write y prime. And that was the idea. Okay? Really the chain rules from here. Try another example. Implicit equation. How about y cubed times e to the x plus ln of y times 3x to the 4 plus 4x squared plus 2 equal to 7. Find y prime implicitly. Y prime or dy over dx, the same thing. Alright? So we're gonna take the derivative on both sides. On the left hand side, we start with the first term right here. I see that I have to use the product rules because I got y cubed and times e to the x. Product rules say what? You have to take the derivative product, take the derivative of the first term times the second. The derivative of y cubed is 3y squared. See? Y cubed, 3y squared. And keep in mind that y is not our variable. Y is like a substitution for a big mass. So you have to multiply by dy over dx, which is y prime. This is the derivative of the first term. And you time the second term, okay, plus the derivative of the second term. The derivative of e to the x is just e to the x, and you time the first term, which is y cubed. You see, I'm using the product rules and the chain rules. Now I'm done with the first term. I'm going to move on to the second term right here. I see another product rules, ln of y times the big mass of x. The derivative of ln, what we're looking for is 1 over y. And again, y is not our variable, with x is. Y is the big mass, so you think of what? Multiply by y prime. This is the derivative ln, and times what? 3x to the 4 plus 4x squared plus 2. And then plus. Now what? Derivative of the second term times the first. Derivative of the second term right here is 12x cubed plus 8x. Derivative 2 is 0 already in time the first term, which is ln of y, equal to the derivative of the right hand side is 0. Okay, now you got a couple of terms with y prime, a couple of terms without y prime. You're going to group the term with y prime together. I got y prime right here. On the left hand side, what left over is what? 3y squared times e to the x plus y prime, I took it out, I got what? 3x to the 4 plus 4x squared plus 2, everything to the y, this part right here, okay, in parentheses. And now I'm going to move all the term without the y prime to the right hand side. So this one to the right going to be negative e to the x, y cubed, and then negative 12x cubed plus 8x, ln of y. Okay, last step, divide both sides by whatever you have in parentheses. So y prime will be equal to negative e to the x, y cubed minus 12x cubed plus 8x times ln of y, everything divided by 3y squared e to the x plus 3x to the 4 plus 4x squared plus 2 over y in here. Okay, and that will be your answer for dy over dx on y prime implicitly. So y prime still depends on y. Okay, let's try one more example of this type. Make sure that we really understand the whole thing. Let me look for an example from the book. Oh, okay. We have this. The book gives you a pretty simple one. X to the 4 plus y to the 4 equal to 16. Alright, but they ask you to find the second derivative. So let's start with the first derivative. Derivative both sides. I got what? 4x cubed, right? So the question is what is y prime equal to? What is y double prime equal to? Okay? Derivative both sides. X to the 4 derivative is what? 4x cubed. Plus y to the 4. Well, y is now not a variable, like a big mass to the 4. So 4 times y cubed. And since y is not a variable, you have to multiply by y prime. And it's equal to the derivative of 16 is 0. Okay? So can you solve for y prime from here? We have 4y cubed. Y prime is equal to negative 4x cubed. See what we're going to do? Divide both sides by 4y cubed. So y prime is equal to negative 4x cubed over 4y cubed. And if I simplify the 4, I got negative x cubed over y cubed. This will be our first derivative. So far, so good. So I got y prime is equal to negative x cubed over y cubed. Question asks you to do one more. I'm getting the first part done. Second step. Can I calculate y double prime? The answer is yes. I see a fraction right here. What can I do? Quotient rule. Okay? Quotient rule say what? Derivative of the top times the bottom, subtract the bottom times the top, and then over bottom square. So we need to practice, right? Derivative of the top is negative 3x squared